So to continue the review, I want to look at picking out a graph or graphing. You may have to do it by hand. So when we graph piecewise, we make a table with both of the equations. We start with the restriction, and then we see which values we need to go towards. So this says x is greater than -1, so we'll do numbers that are bigger than -1. We'll just do a couple there. And then for the second equation, we're going to make a table. And this one we're going to start with -1, but it says x is less. So we're going to put a couple of numbers smaller than -1. Okay? Now you're going to solve this equation for each of these values. Ever how many you did, a few points should be enough. So -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4, and 2 plus 3 is 5. So it gives us enough points. Then we're going to plug the -1, -2, -3 into the second equation. -1 minus 2 is -3. -2 minus 2 is -4. And -3 minus 2 is -5. So let's plot each of these. We've got -1, 2, 0, 3, 1, 4, and 5, 3. Or, excuse me, 2, 5. Then the other side we have -1, -3. Okay, this one should be a solid dot. We have that. And then it keeps going. This one's -1, -3, then -2, -4, -3, -5. This time, it is an open circle, a first point, and it goes in a downward motion. So this is our piecewise, and we're going to use a table to figure it out. Now remember I told you also could do this in Desmos. So you want to type in your equations, and I'm going to get to Desmos, so let's see what that looks like. So the first equation was x minus 3, I believe. And then remember we're going to use the squiggly mark. And then x, and our statement is greater than or equal to -1. So we're going to pick up this panel down here. Greater than or equal to -1. And whoops, that needs to go inside. Alright, see if I can get that to work right for me. There you go. Alright, and then this second equation was x minus 2, and it's less than -1. So x minus 2, where x is less than -1. So I want to move this and pick up this graph. So you can see it shows you where the graph should be. And remember we talked about clicking on that end point to see if it's got a point or not. The red, or the first equation, was closed. The second equation says undefined. So it was open. And you see the circle is open there because it doesn't include it. So Desmos will work. You just have to put it in there correctly, right? Sometimes you are going to get more than one equation. Some of these are taken from the EOCs. So I do want to look at this one. Remember, if it has 2 endpoints, we are only using those numbers, okay? So anything between 0 and 2. So that's 0, 1, 2. That's all we can use. And this is our equation that we're going to use it with. This second equation, it says equal to 2. So that's the only number we can use, okay? And then this third equation, it says greater than 2. So we'll just pick a few numbers, 2, 3, 4. Okay? So now let's look. We're going to plug in a 0 here. 0 minus 1 is -1. -1 squared is 1 plus 4 is 5. 1 minus 1 is 0, plus 4 is 4. 2 minus 1 is 1, squared is 1, plus 4 is 5. So these are the only points I can graph and notice that neither one of those has an equal. So at 0, 5, I have an open circle. At 1, 4, I have a point. And then at 2, 5, I have another open circle. So that is all the graph we have for this first equation. The second one, I can only plug in a 2. So if I plug a 2 in, 3 times 2 is 6 minus 3. So the next thing we have to be able to do is name the equation of a piecewise. And so we want to, most of these are going to be linear. So this first graph here is just a horizontal line. So if we're writing our piecewise, we have an equation that says y equals 1. But it has a restriction where x is less than or equal to negative 2. Because this is where we're beginning, and it's a solid dot. And then we go to less than number. So that's our first equation. This second equation here is also linear, but it has a slope of rise 1 over 1. So it has a mx of 1x, and it intercepts at 0. So plus b would be plus 0, so we don't need that. And then you notice it does have a solid dot again. Actually, no, that's an open dot. You can see a little hole there. And it went to greater than negative 2 numbers. So you have to be able to write the equation of a piecewise. All right? Then we talked about inverse functions. Remember, to find the inverse of a function, exchange the x and y and rewrite it so it says y equals. So we're going to try this one. I'm going to exchange this y for x and this x for y. So I'm the cube root of y minus 1. And it has a minus 4 on the outside. Okay? So we're going to move this minus 4 first by adding it. Then we get x plus 4 is this cube root. All right, you remember to get rid of a root, we take it to that power, whatever the root was. So this is the third root, so we're going to take it to the third power. So the left side is just a parentheses with x plus 4 to the third power. And the right side, we got rid of the radical. Okay? Now, in order to get 1 alone, we're going to have to add this 1 to the other side. Remember, these bars, these parentheses cannot be penetrated. And that 1 has to go on the outside. So, to write the inverse, exchange your x and your y, what we did, and then rewrite it again for y equals. And you could get any kind of equation. Just go step by step. The next thing we look at was transformations. This is how a graph shifts, how it changes, whether it shrinks or stretches, whether it's vertical or horizontal. So I just want to run through these few things right here. This 5 would make it vertical stretch. Vertical stretch of 5. This here, that's my x minus h, remember? I plugged in a positive 2, so we went right 2. Okay? And then this 2 on the outside means we went up 2. Now, you can always use Desmos to do this. We could put in our parent function of y equals x squared, since it's a quadratic. Then we can put in the function they gave us, see how it changed. Okay? So I'm going to try that with Desmos. All right? So we have 5 parentheses, x minus 2, and we're raising it to the square. And then we had plus 2 on the outside. All right, let's just double check that. 5 with a minus 2 squared plus 2. And then we're going to put in our parent function of just x squared. Okay, remember your parent functions, we got that in our notes. Okay, so let's pull this graph down. So the blue one is our original, x squared. The green one is how we moved. Now notice it got skinnier. Since this 5 is on the outside, it was a vertical stretch. It got pulled up. Then we went to the right 2. We were at 0, we went right 2. And then we went up 2. We were at 0 and we went up 2. So, if you graph the parent function into Desmos and you graph the function you're given, you should be able to tell the change. Let's try this next one. It's a root. 1/2 negative x in the root plus 1. So let's do that. 1/2, oops, 1/2. We've got a square root, remember? So I got to get that from my little box. It's a negative x in there. And then we had a plus 1 on the outside. Now, my parent function for this square root is just square root of x. So we're going to hit square root of x. All right, now let's look at our picture. All right, the original was the red one. It's at 0, 0. Notice how we shifted. We went up 1. Our equation over here says up 1. It did reflect, but notice where the minus is. It's on the inside. So it reflected over the y-axis. And then it says 1/2. That's on the outside. And notice how tall the red one is and how laid down the black one is. That means we had a vertical shrink or compression. We mashed it down. It's not standing as tall. Okay? Now I do want to show you if I take the negative out where the x is and I put it in the front, it reflected differently. Okay? So you have to be aware of how it's reflected and be able to describe that. All right? Then you may get some descriptions, and I'm asking you to write an equation. Pay attention to what the description is telling you. So this one says absolute value. So our absolute value is x minus h plus k out here. So we would say vertical stretch down 3. That's verticals on the outside. We shifted down 3. And then a horizontal stretch by 3. So that means inside the bracket we have absolute of 3x. Because remember, if it's inside, it's a horizontal stretch or shrink. So that said horizontal. That means it had to be in there with the x. Okay? And then you may be asked about the properties. So that's what we did yesterday. I did a little video for you to watch before this one about them. So you're just going to describe what happened. For this particular equation, here's the parent function. And we reflected, so that means we went over the x. And we moved to the left 3. So if we're moving to the left, would that be outside the bracket with the x or in there with the x? If we went a horizontal left 3, it would be with the x, okay? So it's important you know if it's vertical, it'd be outside. If it's horizontal, it'd be in there with the x. So those two are out. We did reflect. Notice they both have negatives in front. Because I went to the left, I could type in an equation and move it to the left and see what I did. But our original function says x minus h. So if I went left 3, that means I stuck a negative 3 in for h. So the negative of negative 3 is plus 3. We can always check it in Desmos. Okay? This one has a reflection as well. Notice we've got negatives out here. Okay? Now we've got a movement with the x because we went left to right, or we went up and down. We did not go up and down. Okay? This time we went to the right 2. This is the only one that matches that description. Okay?